Like fireflies on a still summer night, they gently dot and illuminate the infinite velveteen sky. Whenever we look up to the night sky, stars never really seem to change. In fact, throughout one's lifetime, a star may not change whatsoever. Nights after nights, centuries after centuries, people have assumed they lasted forever. But just like every creation of God, stars do have an origin and an end. Stars, be they millions or billions of years old, all born in nebulae, when a dense region happens to form from a huge cloud of dust and gas, mostly hydrogen, starts to fold inwards due to the influence of gravity. As the contracting clump starts to heat up, a protostar is formed. A protostar is a dense ball of gas that is not yet hot enough at the center to start a nuclear reaction. As the collapse continues over time, the mass of protostar increases, squeezing it further and increasing its temperature to reach 10 million degrees Celsius and becomes hot enough at its center for nuclear fusion to occur and becomes a star. The young star then starts converting its hydrogen into helium via nuclear fusion and producing immense amount of heat and light in the process. And these massive energy productions prevent the star from collapsing into itself because of its own gravity and stays in this form for millions of years. Our Sun is one of such main sequence stars. As the hydrogen fuel in the core of the star gets exhausted, the nuclear reaction starts to move outwards into the atmosphere and burn the hydrogen that is in a cell surrounding the core. As a result, the star starts to expand and cool, turning it much redder. Over time, the star will change into a red giant and grow to more than 400 times its original size, engulfing most of its close orbiting planets in the process. And if the star is massive enough, it takes the form of a supergiant. As it expands, the star starts fusing helium atoms to prevent its core from collapsing. Once the helium fusion ends, the core shrinks and the star begins to fuse carbon. The process repeats until iron starts appearing in the core. Iron fusion absorbs energy, so the presence of iron causes the star to collapse. If the star is massive enough, the implosion creates the strongest explosion known in the universe, blowing away most of the star's material out and core collapse into a high-spinning, immensely dense neutron star, or sometimes into a singularity with gravity so powerful that no matter can ever escape from it, not even the massless light. But when the star is too small, like our Sun, the core peacefully collapses into a tiny shiny white dwarf and later turning into a black dwarf, and outer material drifts away as planetary nebulae. Stars, no doubt, are the building blocks of today's universe, are also the cosmic nursery for life. They not only have been the source of cavemen's curiosity about the universe, but also have always been the guiding path for mankind.